Alrighty, today's first task is removing 7805 and replacing it with a modern equivalent. Then replacing the boring red LED with a blue one. So that'll require removing the keyboard. Probably remove this at some stage because it's just going to break otherwise. And also I was going to remove the modulator can carefully and also just investigate what signal is going in there so I can try and convert it to composite. So let's start. Okay, first bit's done. The linear regulator has been removed. So I've used a PSU3 from EZSBC.com or EZSBC.com. I've also put a bit of insulating tape around the crystal there, so there's no electrical contact. I like these ones from EZSBC because you can get them without the pin headers soldered on. Actually, let me get some out. So this is an example of a kind of a professional one, I guess. Well, they're all professional. And you know, you buy them, pin headers are already on, so you're limited into how you can mount it. In this case, if I tried to use this one, I would have been backing onto the power switch. There's not much space there at all, is there? So, but with the ones from EZSBC, you can get them without the headers on, so that I could mount them like this, like that, like that, like fingers in the way, like that. I can mount it however I need for the task at hand. So yeah, so that one's done, and everything's still working. I think it's on at the moment. Switch off. So yeah, so far so good. Next I'll take the speaker off so I don't break the wires anymore. Then I'll desolder the UHF modulator can. Actually, the next thing I did is I took the keyboard off so I can replace the LED. Two types of screws. So I've made a mark. This is the most common one. So I've made a mark where they go, and then there's three other slightly smaller screws. One went there, one went there, and one went there. So I've made a mark where the other ones go. Yeah, that's the keyboard. So a bit of dust on there, so I'll give that a clean. There's the joystick. I'll set the camera up. I don't want to break the ribbon cable. But interestingly, every key is numbered. So position 14, key number 14, 13, 13. Which I'll probably point out with my poker. So number 13 and lines up with key 13 there. So I've never seen that. That's pretty neat. 27, there'll be a 27 on there. Yeah, there's 27 there. So 54, 50. Oh no, was it 54? Just to prove me wrong. Can I zoom in a bit more? That's 53, 53. That one says 43. Oh, okay. Interesting. 43 there. Ah. I assume so. It's 42, key number 54. 43. Must be the same key, no? Interesting. Interesting. 54 and 43. So they've got those two keys round the wrong way. So I don't know. I don't want to. Are they both shift? Yeah, they're both shift keys. So, quality control. Interesting. Anyway, yeah, on to cleaning this up. One of the things always to check when replacing LEDs is to make sure that you have them at the same height if they're not flush, so that they meet the case. So in this case it looks like the bottom of the LED is about 3 mil above the circuit board, so as long as I do that when I replace it, should be the same. So pretty simple. I've taken it off. I'll go give this a wash. So joystick is glued in. I'm not going to unglue it. Seems pretty. Would be nice to just to give it a clean, but I'm sure it's fine. So I'll replace that next, and then should I disassemble and I think it's pretty. I don't think it really needs a clean. I think it's okay. So I'll leave that how it is. Don't want to cause too much work for myself. Now normally I would replace the LED, the boring red LED, with a blue one, but I thought, well, orange might match, so I'm going to give that one a try. Okay, orange LED to match the orange keys. Let's see. Yeah, so this is basically it. I haven't really looked at the board. We have got this is the CDP1871, so that's the keyboard encoder, decoder. That's the 1802, that's the actual CPU. And then we've got the 1869 and 1870, which work together in the VIS, Visual Interface System. I think the 69 handles addressing and also sound noise generation processing, and the 70 handles the I made a note, color video generator. And we've got 2K of RAM there, so it's supposed to have 3K of RAM. That's definitely 2K, isn't it? 6116. I think we've got a amplifier up there. I think this here is the ROM, 16K ROM, HN61 613128, holding the BASIC. And I think this must be the 32K RAM here, M3732. So 32K, 1 bit each, and there's 8 of them, so 32K kilobytes. So pretty simple. So I just wonder, is there like another 1K there or something? Because that's 2K, unless maybe there's, I don't know. Anyway, so LED's done. Regulator's done. Next thing is to desolder this one and check what the video signal's like. Okay, I've removed the RF modulator can from the board. So we've just got the, I guess that's ground, and that is the signal. Well, maybe that's not ground, I don't know. I think it's ground. I assume it's ground. Anyway, so I removed that. Normally I gut these and I reuse the RCA here, so that's the case of heating these up, these solder blobs up here, actually removing the resistor from the RCA there, and then just pushing the board out. Yeah, pushing the board out from the bottom, so this is all empty. And then I can put something else in here and then reattach it to the board like that. So let me set the camera up. Okay, so yep, so that's done. Now to convert to composite, so I've had a look. This is the original data sheet for the CDP1870, if I may show you. And actually it's got separate chroma and luma out, so maybe even S-video is possible, and composite sync here. So we've got chroma, a couple of 120 picofarad capacitor, sync going in there, variable level, so we're going to adjust the sync level. Then we've got this video level here, 10K variable resistor, basically going out to the monitor or to the RF modulator, which is what I've removed here. So that is a starting point. But on the COMX-35 modern reproduction, looks like they've got a emitter follower, a buffer emitter follower. Let me fold it up so it's easier to show. So again, we've got Luma, composite sync. Now the chip, you tell the chip whether you've got NTSC or PAL via, well, basically it looks like you've got NTSC and PAL chroma output on separate pins. So 120 picofarad for the chroma. Is this sync level here? Must be sync level there. 10K. Yeah, so it looks like setting the sync level there with the 10K variable resistor, setting the variable level, the video output level there, 10K variable resistor, and then going into this emitter follower. So 10 ohms, 220, and then 75 to match the impedance of the composite output. So I'm assuming we've got these already because I can see two variable resistors on there. So I'm planning to implement this into the modulator. Can stick that into there as I've done before on ZX81s. So there are two variable resistors there and there. It's not powered on, so don't worry about using metal. Anyway, so I'm assuming that that's that. Maybe this is the 120 picofarad. I don't know. I'll have to trace it out and see. So that's what I'm going to attempt. I don't know if I said before, but I've got the amber to match the key. So let's see. Okay, I found it. Let me get my poker. So there's our 120 picofarad capacitor, and there is our sync level, 10K variable resistor for the sync level, and that is then connected over to here for the final video output level, which goes onto that wire there. So that is pretty much as per this diagram here. 120 picofarads there, 10K for the sync level, 10K for the video level, and then straight out to the monitor. So I will go off this, I think, and just add in that that buffer there, the emitter follower, because we've got, see, we've got the 10K there, we've got the 120 picofarad there, we've got the 10K there. So pretty much, yep. I'll replace this wire. I think that's ground. Replace this wire, and then whack all that inside the. Stop the video. Inside the modulator cam. Getting there. I've applied a lot of heat and got the solder disconnected off the wall there. I also disconnected the resistor that was attached to that, so because I don't, got to be very careful, I don't want to damage that. That one's still attached, but who cares? I don't need the board, so I don't mind if I break it. La 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 la. There we go. So it's just a matter of cleaning it up. So I need to get 5 volts in here. 5 volts video signal and ground. Well, ground is easy. So it's just a shame that that's, I don't know. I think I can turn that around. Let's see. Anyway, I'm going to clean it up. Yeah, all right, let's see. So yeah, cleaning it up means basically just getting rid of the excess solder, smoothing it out. Case gets very hot. Surprise, surprise. Probably could use the desoldering iron here. Ow, ow, ow. There's a bit of solder there as well. Okay. It is hot. Owie, owie, owie. Okay. So the idea is to put the bottom of the case back on. Bottom of the case back on. Like so. Okay. Stick this insulating cardboard back in the bottom. Like that. This insulating cardboard goes on the bottom under that, like that. And then that's where my little middle follower will go. Okay. Let's build that next. So I'm just looking at how I'm going to do this, and this wire here that was pretty much soldered, I've now sucked it all out, but it was soldered to the case basically. I assumed was ground, which is also there, but it is actually connected to that 33 ohm resistor and 47 microfarad capacitor. Yeah, so that's the capacitor there. There's obviously ground connected to we've got the resistor, which is actually 5 volts there, going to that wire that went in. So I'm wondering whether to remove these two. We'll actually replace I need 10 ohms. 10 ohms from VCC, and then a wire in, and then connect this to the collector. Maybe. Okay, so I've removed the 33 ohm R33 and the 47 microfarad from ground, C33. So my idea is to put the 10 ohm resistor in here, then I'll have this wire going, then I'll put a wire going into the case to the collector on the transistor. And then we've got ground inside the case anyway, and then this will be the video output that goes into the base. And then inside we've got an emitter going to, the emitter's connected to ground and to the output. That's the plan anyway. Alrighty, this is my first attempt. Not pretty, but well, yeah, let's see. Marker on there, wherever the holes are, and then just got 10 ohms there coming from VCC, and then just wire the 2 wires in and see if it works. Gutted the RF modulator, and Composite's now working. And orange power LED, and replace the linear regulator. So far so good. Okay, I'm now finished. Running these, they're no need for heat sinks. They're all, if anything, they feel colder than ambient. I realised just fiddling with that gets the basic prompt up. So now I can test the keyboard. So I'll put the lid back on that. Nothing else really to do. I'm just hoping the case goes back together with that rather tall regulator. Yeah, there we go. All right, put it back together. Before I close it up, so just to confirm, yes, I removed C33. I replaced R33 with a 10 ohm, and then that's gone into the collector of the transistor. I've got the base connected through to the 10K video level variable resistor, and then the emitter, we've got what, 220 ohm to ground and 75 ohm to the RCA connector. Yeah. Right, one final change before I put it back together is I've just made it so you can detach the speaker. If I ever pull it apart in future, I can just leave the speaker screwed onto the baseboard, bottom case, and just unplug it. There we go, all ready to go back together. So I've put that on there just so I can, in future, don't have to desolder it or whatever, we can just leave that attached to there. Composite video done, linear regulator replaced, orange power LED. I was thinking I probably should have changed, I don't know, I didn't change any of the capacitors. It's working. So next thing is I want to try and get some software loaded, so I'm just going to leave it as it is. So gotta get over the power. Okay. Okay, coming back together. Clip down the front, 4 clips. I'll just use, I'll just dust that off. So I probably could have taken all this out and washed it, but whatever. And then 2 screws at the bottom, and we are done. It was working. Let's hope it's still working. Oh yeah, you can see here, mix. Okay, so yeah, through hole for the sink, variable resistor for the sink, and for the video level. Must go through the circuit board through to the variable resistor on the other side. So there we go, all back together. I might just give the front a bit of a dust. All right, we're all back together. Power supply's on. Beep, 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 beep. Working. Okay. Only problem is HJ, some keys aren't working. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like we have to pull her apart again and yeah, fix that. So I've got the amber. So if I turn off this light here, that might be a bit better. So we've got the amber to, I don't know, I like it. And power 0.13, so it was 0.2, so saving 70 milliamps by using the switching regulator. Yeah, so we're getting there. I think the next step will be to fix the keyboard and then try and find some software to download.